Welcome to our Algebra Play Pause It for the week. I know it's a little bit different than what you're used to because of the holiday, but it's going to function the same way. So go ahead and grab your notes for today. They're in that Play Pause It folder. And then also, if you wanted to go ahead and have your Play Pause It graded assignment open so you can put those answers in as you go along. Don't forget, at any time, you guys can pause the recording to work the problems out on your own and then press play to find the solution. So in class yesterday, we went over solving and graphing inequalities. So here's one that looks a little more complicated. I see things on both sides of the equal sign. Now what we want to do is we want to solve for x. So I'm going to distribute the 4. So 4 times x is 4x. 4 times 1 is 4. And then I'll bring down everything else. Now the goal is to combine like terms. So we're going to move the 4x over. Remember, we said solving inequalities is just like solving equations except for one difference. Remember the one difference in solving inequalities? What happens if we divide by a negative? You have to flip the inequality. Inequality. Something I want to point out that we didn't really specify in class yesterday is it's not just dividing, it's also multiplying. And let me show you why. So we're just going to put this problem on hold for a second. And let's say we had negative 2x is less than 1. And we were going to divide by a negative 2, right? So you're like, okay, I need to flip the sign, flip the inequality to greater than, and get negative 1/2. But check this out. If we have negative 2x is less than 1, isn't that the same thing as multiplying by a negative 2 over, by a negative 1 over 2? Isn't dividing by 2 the same thing as multiplying by negative 1 over 2? It's the same thing. You're multiplying by that fraction. It'll get you the same solution. So it's either when you multiply or divide, both, you're going to flip that inequality. So I want to make sure to clarify that for you guys. All right, going back to our warm-up here, we're going to move the 4x over by subtracting it, doing that opposite operation. Look what happens. On the left here, we're left with no x's, and we get 4 is less than or equal to 3. Now, just like solving equations, sometimes this can happen with solving inequalities. What do you guys think this means? And hopefully you're all yelling at the screen. This means no solution, because is 4 less than or equal to 3? No, it's not true. So in this case, it is no solution. So I wanted to show you can see the same thing with inequalities. So today I do want to make sure, because I was absent last week, my plan last week was to go over some of the notes that we missed the week before. But because I was absent, I couldn't do that. So I just want to make sure that we all have our notes that we need from September 29th. And I know that feels like a world away, but I didn't want to just forget about them. So if you want to grab your notes from September 29th, maybe pause this video. We're going to finish those notes up. And then we're going to take the linear inequalities we've been working with, and we're going to put them to some real-world applications. So I know we talked about this yesterday, but just a reminder that Ms. Jadala is having some extra Algebra 1 help sessions, and these are going to happen every single week, and they're going to be listed by topic. So for this week, she's going to be holding a session on solving linear equations, the really hard ones. And then the same day, she'll have her open office hours. And then on Thursday at 9 o'clock, it'll be doing what we did in class yesterday, solving linear inequalities. But they'll be multi-step, so you'll also graph those. And then Wednesday next week, we have on the docket for Unit 2 review. I haven't put the topics yet for the 12 o'clock session, I'm sorry, for the Thursday session, you'll see that on your schedule. So if you're interested in coming to any of these, you can just drop in and you'll find that topic listed on your Class Connect schedule. Don't forget, you want to have that Desmos graphing calculator handy as you're working through your lessons. This will be the calculator that you have on the SOL, so you want to get used to it. All right, so these are the examples from September 29th that I wanted to make sure we went through. And I remember one class in particular, we were working through this example and we didn't get to finish it because time ran out and we had gotten an answer that was interesting. So let's go through this one. These are the conversion problems. So it tells us that Lynn feeds her cat 65 grams of food per day. How many ounces of cat food will she feed her cat in 5 weeks? And it gives us this nice conversion here. It doesn't expect you to know how many grams are in an ounce. So I like to always start with what I'm given. We're given 65 grams. And I make it a fraction because I know I'm going to be multiplying by some fraction. And we're going to use the conversion here, and I'm going to put the grams on the bottom. Think about, why do we put the grams on the bottom? And that's because we want these to cancel out. So I'll put the ounces on the top because that's what we want in the end, right? We want ounces. So then I'll just fill in the numbers that gave me 1 and 28.3. So the grams will divide out and you'll be left with 65 ounces over, or 65 over 28.3 ounces. Let's see what that is. I'm going to use my calculator. I have the Desmos on my phone. You guys all know you can download the Desmos app on your phone too. So we got 2.297, we'll go ahead and round that, ounces. But remember, that's just for one day. We want to know for 5 weeks. So there's kind of a few ways to do this. I'm just going to go step by step. So if this is for one day, how much is it for 7 days? Because there are 7 days in a week. So I'm just going to multiply this by 7. And that gives us 16.08 approximately. So that's in 1 week, right? But it wants to know in 5 weeks. So we're going to multiply this by 5. And the final answer is 80.39 ounces in 5 weeks. And I remember one of the classes that I had, I think it was my 11 o'clock, we got straight to this answer. And then I ended up, I think we were like trying to multiply again by 7, and it's like, oh no, I think we should have just stopped. That was the answer. So I think whoever was helping me out with that went straight to the answer, and that's kind of what happened there. But if you wanted to, you could also go straight to 5 weeks. If you kind of calculated there are 35 days in 5 weeks. So you could also do that, however you see that. All right, here is example 4. There are 7 more dogs. Let me get my highlighter because it's fun. 7 more dogs than cats in a kennel. There are 23 dogs and cats in all. How many dogs? All right, so they tell us to let D represent dogs. D is the number of dogs. Oh my gosh, can you guys hear that? That's my cat killing my couch right now. There we go. All right, so if D is the number of dogs and there are 7 more dogs than cats. So let's think about what would C be? How many cats are there? Well, there's more dogs, right? So D is going to be the bigger number. So I'm going to write this and let's talk about it. C, the number of cats is D minus 7. And you might be saying, well, it says more than. Why are you doing subtraction? And I totally understand that thought process, but it's because there are 7 more dogs than cats. So because I made this cats, so because I made this C here, cats, you have to think, okay, I would take the total number of dogs and take 7 away to get the number of cats. Let's look at this now. there are 23 total. So I'm going to take dogs, that's D, plus cats, well, cats is D minus 7, equals 23. So we're just adding them all together. We represented cats as D minus 7. So now let's combine like terms. 2D minus 7 equals 23. And then we will add 7 to both sides. And you get 2D equals 30. Now just keep solving for D. Remember the inverse of multiplication is division. So divide by 2. D is 15. There are 15 dogs because there are 7 more dogs than cats. So let's see how many cats are there. We would just take this D and plug it in. So cats equals 15 minus 7. So there are 8 cats. And that makes sense, right? If there's 8 cats and 7 more dogs, that means 8 plus 7 is going to be the 15. So anytime, you guys are welcome to rewind this, play pause it to review anything, take notes. All right, so I wanted to know if you guys recalled this question that we did in one of our play posits. I think it was about 2 weeks ago. And we created a cost equation for my babysitting for my daughter, Sophia. She's so sweet. This was our cost equation right here. Recall the meaning. What does the 15 stand for? Now the 15 is the rate of change. It's what's changing. That is going to be the per hour fee. So it's going to change based on how many hours I hire the babysitter for. So that total value of that term will change. And then the 10 is the constant. That stays the same. That's that flat fee that we talk about. This is the rate of change. So just a quick review over here. Recall the parts of an expression. How many terms does this have? Remember, terms are separated by addition and subtraction. So it has 1, 2, 3, 4. 4 terms. Terms are separated by addition and subtraction. All right, let's see. What is the constant? Remember, the constant term is the one that's never going to change. So it has no variables with it. So that is -6 here at the end. And then something we haven't spoke about yet too much is the leading coefficient. The leading coefficient here is 2. It's the coefficient in front. Remember, coefficient is the number in front of those variables. We're actually going to learn more about leading coefficient when we get to graphing linear functions. All right, so true or false. Number 1, the expression has 4 terms. This is true. There's 1, 2, 3, 4 terms. Number 2, the coefficient of the third term is -6. That is true. Here's the third term. Coefficient is -6. Number 3, the second term is constant. Nope, the second term is a variable. It's C, so that's false. And lastly, the third term is 6xy. So be careful, I tried to sort of trick you here. The third term is actually -6xy, so you want to make sure to grab that sign in front. All right, so here's examples 5 and 6, and then I think we're almost done with those notes. So here's our example. We have a souvenir shop. They give you an expression to represent Javier's total cost in dollars for buying some postcards and a bottle of water. So some postcards and a single bottle of water. So which of these is going to change, do you guys think? A bottle of water or some? Do we know how many postcards he bought? No, but we do know how much water he bought. He bought a bottle, just one bottle. So this is going to be the constant. Kind of have to look at those words that are put in there. A bottle. And some, meaning we don't know how many. So that's going to be the variable. So which statement is correct? Which value is with the variable? That's the 1. So that means, whoops, too many ones. That means the postcards were $1 each. So that's number 2. Postcards cost $1 and the water is $2.25 because that's the constant. There's no variable with it. All right, example 6. Here's our expression. Grab my highlighter. And this represents the balance in dollars of a bank account after X months. So what is the rate of change in dollars per month? And we kind of talked about this a little bit with that babysitting example. The rate of change is the -50 per month. The rate of change exists with the variable because that's what is changing, right? The X is going to change. So -50. So what does that mean? What would happen after 1 month? He would be down $50, right? -50. What happens after 2 months? He's down $100. So let's hope he's also putting some money in. He has a original balance of $250. That's his starting point. So after a while, I wonder after how many months will he have a negative balance based on this equation? That's a fun follow-up question. Think about that. After how many months would he have a negative balance? We could just try it out. Like I said, if you did, let's try 3 months. If we plugged in 3, that would be a -150. So that's still positive. $100 left. How about 4 months? That would be -200. So we'd still have $50 left. I think we're getting closer. 5 months, that would be 25. He would have $0 after 5 months, right? So he would have to go 6 months to get that negative value. Although I'm sure the bank would be calling him after 5 months because you can't just have $0 in your bank account. you shouldn't. Here is example 7. Here's an expression that represents the elevation above sea level in meters of a rock climber after climbing X minutes. What is the rock climber's initial height above sea level? So this word initial here is a big tip off to what they're looking for. They're looking for that constant value, that starting point. Just like in our bank account example, remember we started with $250 and then it changed monthly. Here we start at 50. So it is 50 meters. And then we're going to change based on this term, based on however many minutes we're climbing. So after 1 minute, we've gone 2 meters. After 2 minutes, we've gone 4 meters. After 3 minutes, we've gone 6 meters. You guys see that? But we've already started at 50 meters above sea level. So it's that initial height. All right, here's our last example, example 8. They give us an expression right here, and this models the amount of money, the amount of sales tax charged on a particular purchase that included a % discount and a money off. So let's talk about a few of these things first. So a sales tax charge, whenever you're going to be charged sales tax, you know, they might say there's a tax of 4.5%. But we never multiply by percent. You'll notice there's no like percent button on your calculator. Remember, we have to convert this to a decimal. To do that, all you have to do is move the decimal 2 places. And you get 0.045. So that would be the tax rate as a decimal for this example, just this little example up here. We're not going to actually be converting in this class, but I just wanted you to see that a sales tax is going to be shown as a decimal. So you can see in this equation or this expression, we have lots of decimals going on, so that makes sense. A percent discount is done the same way. So if we said there's a 10% discount, again, we wouldn't multiply by 10 because there's no percent button. We have to multiply by the decimal. So we would move that decimal 2 places to the left. And hopefully you guys, this is refreshing your memory because you did this last year or the year before. And we would get 0.10 to multiply by. So again, a percent discount you're going to see as a decimal. And then lastly, money off. Money off. When you think of off, hopefully you're thinking of subtraction. So this is going to be subtracting some money. So one example might be a $5 coupon. It would be -5. Oh, there's a 5 in this example. All right, so let's match these up. So it kind of depends how you want to go. We could go left to right. The sales tax rate. So there's 2 decimals in our equation that we can choose from, the 0.9x and the 0.07. One tip, though, it tells us is the sales tax is charged on the purchase that includes the percent discount. So when you go to buy your shirt, first they're going to take the percent discount off, then they're going to take the money off coupon, and then they're going to charge you tax. You are only charged tax on the actual cost of the item. So it's going to be this 0.07. Let me write the big equation down here. Whoops. It's this one, because you're multiplying that tax rate by everything, the entire value of the shirt. All right, the money off coupon is the -5. We talked about that. That's just taking off that monetary value straight off the top of the price. And then the cost after the percent discount is deducted from the original price. That is this one. So our percent discount, X is the original price. They tell us that. So that was the big tip off there. Original price, original price. You're multiplying that percent discount times the original price. So lastly, this is the total cost before tax is applied. Remember, here's that piece right there. That's how much it's going to cost before we multiply it by that 0.07. So I know these can be a little bit challenging because you're kind of combining a lot of different topics here. Sort of the knowledge behind percents and money off coupons and some of this wording here like original price. So I do think these take practice. If you guys need help on these, let me know. All right, look at the kitty. Let's get to our application questions for our inequalities. So a lot of this should hopefully look familiar because we're going to be doing some translating. So remember we did some translating with expressions and equations. So we're also going to do translating with inequalities. Remember that's turning English words into math symbols. So it tells us the length of a rectangle is 3 times its width. The perimeter is at most 112. Let's write an inequality to model the relationship. So let's just start at the beginning. The length is 3 times the width. So see, all I did was I took this first sentence and I translated it into an equation. Then it tells us the perimeter, so P, is, well, let's look at this, at most. So this word at most is really important. That's going to help us decide which inequality to use. So if it's at most 112, can it be 113? No, because it says the biggest it can be at most is 112. So that means it's allowed to be 111, 110, 109, 108, 107. So it's going to be less than 112. I also put equal to because it says it's allowed to be at most this value. So we can be that value and less. So this can be a little confusing for people because you see the word most and you think it should be more. I should have greater than. But we need to sort of think about what that means. It can be at most 112, which means it cannot be more. So we're going to have less than or equal to 112. Okay, now the last step says to write an inequality to model the relationship between the width and the perimeter. So let's remember what the formula for perimeter is. Remember, perimeter is the distance all the way around an object. And here we're talking about a rectangle. So there are two lengths and there are two widths. So if you forget this, you're also welcome to use the formula sheet for our class. You can find that in our content folder in the OMHS. It is on there, or I'm guessing most of you recall the perimeter formula. All right, let's plug in what we know. We know L. So L is 3W, right? Plus 2W. Now let's simplify this. 2 times 3 is 6. 8W. Oh, I forgot. We'll do less than 112. It shouldn't be. We should write this here. Right? Because the perimeter should be less than or equal to 112. Now we're going to divide both sides by 8. And we can keep the sign the same or keep the inequality the same, and we get 14. So W, the width must be less than or equal to 14 centimeters. And if it's not, if it happens to be bigger, then we're not going to be able to satisfy this requirement here about the perimeter. So this could actually come in real handy, especially if you're trying to, I'm guarantee you that people who put in fences use this formula or some version of it. You know, people will hire a company to come and put a fence in their backyard, for example. They're going to need to know how much fencing to purchase for that space. All right, let's talk about Eduardo, who started a business selling sporting goods. He spent $7,500 to obtain his merchandise. So just straight up off the top, he had to spend a flat fee of $7,500 to get his merchandise. And then it cost him $300 per week for general expenses. So maybe his employees or marketing, or if he owns a shop, his rent, although 300 is pretty cheap for all that. Nonetheless, each week he has to pay $300 for general expenses. And he earns $850 per week. What is the minimum number of weeks it will take Eduardo to make a profit? So he's already put out this big sum of money, and he's putting out this much per week. So when is this per week income going to balance out to where he's actually putting money in the bank? This is something people use all the time. All right, so let's look at our options. Well, first of all, what do we want to be on the, here it's funny, they have the, what we would consider sort of the solution on the left-hand side. And that's totally fine. It's just that we're used to seeing it on the right-hand side. So we want 850 there, right? Because that's what we want it to be. That's how much he earns. So it's definitely not going to be A because we have 300 there. So now let's look at these. The only thing different in these two is the way that the inequality symbol is facing. So we need to think about, what does this mean? The minimum number of weeks. So if you look at what's going on over here, I'm going to write it out. What does all of this represent? Because that's what's in both of these, right? All of this represents how much money he's spending, right? He spent $7,500 as his flat fee, and then he spends $300 a week. So we want this value to be less than how much he's making eventually. Or if you think about it, we want how much he's making to be more than all of this, right? Because once it's more than, we know he's making a profit. If what he's making ends up being less than what he spent, then he's still in the hole. So we want what he's making to be more than, and that is B, with the greater than symbol there. So this one didn't involve much math in the sense we didn't do any computation. It was more logic there. And knowing what each part of the equation represents, or each part of the inequality. All right, let's talk about Mia, or Maya. Maya? Maya is 3 years older than twice. Oh, this is fun. Maya is 3 years older than twice her sister Brooke's age. Okay, I'll admit these problems are just sort of silly and fun, sort of brain teasers. I don't think anyone actually sits around and does this like in the real world. I'll be honest. The sum of their ages is less than 30. What is the greatest age that Brooke can be? Oh, so this is a really good example of what I was talking about earlier when we're going to be translating. Okay, so Mia is 3 years older. So older, we think of addition. 3 years older than twice her sister's age. So 2 times B. We'll call Brooke B. Here, let me label that. Brooke is B. So Brooke is B age, B years, and Maya is twice Brooke's age and then 3 years older. All right, so now let's use this clue. The sum, so sum is addition, of their ages is less than 30. So I just wrote is for the equals, but let's see if it really should be less than or equal to or just less than. Let's look. So we're going to add them up. We're going to sum them. So there's, I can't remember if I called it Mia or Maya. There's Maya's age plus Brooke's age. Oh, and it must be less than 30. This is more of a English constraint there than the mathematical is of equal to. All right, now let's solve for B to see how old is Brooke. So 3 plus 3B, I think I'll never use this problem again because it's just so silly. No one's going to do this. You guys do this kind of math? All right. Hold on. Okay, now let's get B by itself. So we're going to subtract 3 from both sides. By the way, I am alone right now in my office laughing at myself. I wish you guys were here. I feel silly. All right, now we're going to divide by 3. So B is less than 9 years. But what does that mean? Excuse me, Isabel. Sorry. What does that mean? Brooke, B is less than 9 years. So the greatest age Brooke can be is what? Can Brooke be 9 years old? No, because it says Brooke is less than 9 years old. So I would say for the sake of this problem, when we're talking about age, we'll stick with years. You know, when you're like a baby, usually you consider someone's age to be months. Like she's 3 months. You wouldn't say she's, like a quarter of a year, a third of a year. It'd be one fourth of a year. So we're gonna stick with years here. So she can't be 9 years old. She must be less than 9 years old. So what would be the next year that would make sense? And that would be 8, right? So the greatest age Brooke can be is 8 years old. The end. Goodbye, Brooke. Silly problem. All right, here's our next one. The sum of 2 consecutive integers is at least 185. So these are kind of silly too, but they're more like brain teasers. I get these. You're going to actually see problems like this on the SAT as well. So let's label the first integer as x. We'll just start somewhere. Any integer x. We'll just call it x. So what would the next integer look like? What would the next integer look like? Well, here's an example. The first integer is 1. What's the next integer? It's 2. Okay. If the first integer is 4, what's the next integer? It's 5, right? So each time we're just adding 1. So if the first integer is x, what's the next integer? X plus 1. All right, that's the hardest part, I think. So now let's use this. The sum of two consecutive integers is at least 185. So let's sum the integers. We're going to add the first integer to the second integer. X plus 1. Now it says that is at least 185. That means it can be 185. It can be 186, 187, 188, but it's at least 185. So that means it's greater than or equal to 185. Can it be 184? No, so it's not less than. So let's solve this. We got 2x plus 1 is greater than or equal to 185. Subtract the 1. You guys probably got this down by now, right? 184. Then we'll divide by 2. X is greater than or equal to 92. So the smallest it could be is 92, right? Could it be 91? No, because it says x is greater than 92 or equal to. Could it be 93? Sure. But the smallest it could be is 92. So the smaller of the two integers is 92. It can't be anything else. It can't be 91 because it tells us x is greater than 92, greater than or equal to 92. Hey, look what I found. I Googled, I looked up. All right, here's our last one. Vanessa has scored these scores on 3 math quizzes. Oh, I've actually legit used this formula, so this is real. She will take one more quiz, and she wants a quiz average of it at least 40. So we're not talking about percent here because 40% would not be great at all. Her teacher must use points. So she wants to get at least an average of 40 on her quizzes. What is the minimum score Vanessa needs to earn on her 4th quiz in order to do that? So we need to know what's the average. Average. Do you guys remember how to find the average? How do you find the average of 2 numbers? You add them together and divide by however many there are. So let's find the average of 2 and, 4. We would do 2 plus 4 divided by 2. 6 over 2. So the average of those two numbers is 3, which makes sense because that's right in the middle. So to find the average, you add them all up and you divide by however many there are. So we have the first quiz. Whoops, that's not the first quiz. We have the first quiz of 45, the second quiz, the third quiz, and then the 4th quiz, we don't know. We want to figure out what that should be. So we're going to use x divided by 4. That's a terrible line, sorry. And we want this to be greater than or equal to 40. Because remember, she said minimum. So again, think about what that means. Sometimes people see minimum and they just think less than because it's minimum is small. But that's not what that means. We want it to be a minimum score. So that means it can be more than. But it's got to be at least 40. At least. It could be 41, it could be 42, so it could be greater than or equal to 40. So now let's solve this for x. We're going to combine like terms on the top. When you add these 3 guys, you get 114 plus x over 4. We'll multiply both sides by 4. And we're going to end up with this. And then we're going to subtract 114. And x is greater than or equal to 46. Sorry, I all of a sudden started writing like at a slant there. I don't know what happened. All right, so it says x is greater than or equal to 46. So x can be 46, X can be 47, 48, 49, 50. Can X be 45? No, because it tells us it must be bigger than or equal to 46. So the smallest value that X could be is 46. That's the minimum score she's going to have to earn in order to get the average of 40. All right, you guys, you did it. Bye. No, but for real, if you guys need more help on this topic, remember that we are going to have those sessions with Miss Jadala. There's not a specific one on this yet, but it will be included in the Unit 2 review session next week. You can also reach out to me with any questions, and I'll see you guys next week. Bye.